We have the third question for the Codeforces Round 724, Division 2, and this question is Diluc and Kaeya. So the question statement starts with the quote and the icon of one empire and so on. So this time the brothers are dealing with a strange piece of wood marked with their names. This piece of wood can be represented as a string of n characters. The characters are either a D or a K. We want to make some number of cuts, possibly zero, on this string, partitioning into several contiguous pieces. So basically, with a length of at least one, both brothers act with dignity. So they want to split the wood as evenly as possible. They have their definition of evenly, which is that the each piece of wood that we get after cutting the string should have the ratios of number of occurrences of D to the number of occurrences of K the same. So basically, if we have two occurrences of D and one occurrence of K in one piece and four occurrences of and two occurrences of K in other wood, this is a good cutting. So this is cutting is allowed, but one with 1, 0 and another with 2, 1 is not allowed because the ratios are different in this case. So Kaya, our curious thinker, is interested in the solution for multiple scenarios. So he wants to know the answer for every prefix of the string. So we want to help him solve the problem. So with that, we have the definition of ratios and also the definition of equivalence of ratios, which you can read on yourself. And after that, we have again the definition of ratios. And so basically, we will be given the length of the input string and then the string itself. And for each index of the string, we need to calculate the a maximum number of cuts, a maximum number of output strings that we can get after cutting the initial string up to that point. So basically for DDK we have one for the first index, so basically only the letter D is there. For the for the string DD, which is the second index, we have two because we can cut this into maximum of two, that is for first one D and the second also D into two pieces, and after that DDK this can be cut into maximum of one piece with this ratio same, that is 2:1, that is DDK. So after that we have six Ds which represent 1, 2, 3, 4, 5, 6. So this would this number can be achieved by just saying that after when we get n number of Ds only as an input, then we can cut this into n pieces with each one with a D, and this would give a ratio of 1:0 for each one, and this will be good. So basically the algorithm for this is really simple. So what we have here is, let us say we have this string as an input and we count the number of Ds that have occurred till this point and number of Ks that have occurred till this point. So 1:0, 1:0, 2:0, 2:1, 3:1, 3:2, 3:3. So these are the number of Ds and Ks. So we convert this into these ratios: 1:0, 1:0, 2:1, 3:1, 3:2, 1:1. This can be done easily by calculating the GCD of the two values and then using the division, that is using D by G and K by G, and this we can store this D by G and K by G into a vector which can then be which can then be appended to a vector again, and this would store the ratio, and so basically 1:0, 1:0, 2:1, and so on. So we now come to the algorithm. So basically, let us say these for some other case we have these ratios as a result. So for the first element this, for the second element this, and for the third and for the fourth. So basically, let us say only for the last element. So for 1:1, we can see that 1:1 occurs over here and also over here. So basically, up till this point also and up till this point also, we have the ratio 1:1. So we have equal number of D's and K's up to this point and equal number of D's and K's up to this point. So basically, subtracting this this part. So basically, dividing this into two parts. This part so total minus this part must be equal to this part. So total number of D's, let us say the total number of D's are D and the total number of K's are K. And for the for this initial one we have D and we have K. So basically D minus D, because D minus D and K minus K is the number of D's and K's in this. So basically the ratio will be the same, because D is to K is 1, and D is to K over here is also 1. So basically this is uh, D minus basically this is also capital D minus small d, and this is also capital D minus small d, which are equal and have a ratio 1:1. So this is a 1:1 also, and this is a 1:1 also. So what we can say is that we can count the number of times this ratio has occurred up till this point, then assign that value to the index. So basically for the dk 1 we have 1:0, 1 1. This is the same as this case. So basically we have 1 over here, 1 over here, 1 over here, because these are the first instances of this ratio. And for this we have a 2, because this is the second instance of the same ratio. So 1:1 occurs over here, 1:1 occurs over here. So basically this is adding 1 to this one. So basically this is the logic for the question, and this this is the code, and you can see the code is really simple. So the code in this code, we just take the input string, and then we define a map MP from vector to an integer. So this will store the ratios, and up to which point they have occurred. So basically this is the maximum index, and up to which they have occurred. So basically we will iterate through, and we will keep on increasing D and K appropriately. If the character is D, then we increase D, and if the character is K, we increase K. So this will keep the count, and we calculate the G by using the GCT function, and then we use the temp array, which will store the ratio. So D by G and K by G. So if this function tells us, so if the number of times temp has occurred in MP, that is map, is equal to 0, we will just assign 1 to that value, because this ratio has not occurred yet, and this is the first instance of that ratio. And if it has occurred, then we will go to the else statement, which just appends 1 plus the number of times it has occurred, that will be given by the return value of the previous index that it occurred. And after that, we as we want the maximum value for that ratio, we just assign I to that, that is the index, and then we output the rate. So basically we have, for DDK we have 1 to 1, and these are the required outputs. So for checking if our code is correct, we see our code is accepted, and the time is 5:45, and memory is really small. So thank you.